Hello, it's Keith here, and this is lesson 30 of the platform-specific series of my 68000 assembly programming tutorials. We're looking at the Sharp X68000 today, and we're going to be looking at how to control the mouse. Now, the X68000 was kind of the Japanese equivalent of the IBM PC for the time. It was very popular, became very powerful over the years, so it's no surprise that it supports a mouse because that was the thing of the day. And X68000 had a very fine mouse, and it's actually got a the operating system actually supports the graphical work and the reading of it for us. There is some vague documentation on directly accessing the hardware, but it's very complicated, and using the operating system is very simple. So while I generally don't like using the operating system, I am going to do so in this case. Now, to use the mouse, we use a variety of the functions of Trap 15, and we're going to go over some of the core ones today. You can see here we're reading the mouse, we're showing the cursor to the screen here, and we can move the mouse around the screen, and we can click, and we're actually reading all of that in. And we're going to go into the details of how that's being read in and where the values are appearing on this screen later on. We've also got a range specified. I can't actually go over this position here, but that's been configured by us. We can change the range. We can also turn the mouse cursor off. So that's all things we're going to be looking at today. I just need to press F12 there to turn off the mouse capture. So Trap 15 does provide a variety of functions that we might be interested in for controlling the mouse. You can see them all listed here with details of what registers you pass in and what results you might get out depending on those registers. But we're going to be just looking at the basic ones today, just enough to get you started, and then hopefully if you want to go into more details with regards to sort of animated cursors and things, then you can hopefully look at that yourself. But of course, when it comes to cursors, you might want to just use bitmap graphics or a sprite and just draw your own anyway, so I'm not sure whether that would be something you'd need. Anyway, let's go over to the source code. Let's take a look at what kind of thing we're dealing with. Okay, so as the text up there says, you can download the source code for this and all of my tutorials on my website, so you don't need to type anything in. You can download this and have a go straight away. Right, so we're using Trap 15, so we just call this with Trap 15, and that is going to call the operating system, and that will allow us to get some feedback from the mouse or configure the mouse. And the first thing we're doing is we're using function hexadecimal 70, and this is the initialization function. Now, we don't need to do this, but it would be best to just sort of reset the mouse as we start up to make sure everything's set up correctly. Our next function we're using is function 71, and this turns the cursor on. So we've turned the cursor on, and you can see that cursor just here. If we just wait for our emulators to load up here. So we can move around. You can see that little blue cursor there moving away. So that's our mouse cursor. If we've turned it on but we want to turn it off, we can do so. We just use function 72 to do that. If we just run again here, where you can now see we've got no mouse cursor, but if you look at D0 and D1 in the corner here, you'll notice they are still changing. We are still reading in input even though we can't see the cursor. So as I say, if you're running in a graphical program, if you're writing a game, you might want to draw your own mouse cursor without using the firmware functions and just use the firmware to read in the values from the mouse. So that's an option as well. Now we're going to have the mouse cursor on. The next function we might want to look at is function 77, and this specifies a range, and we use two registers to do this, D1 and D2. D1 specifies the top left and D2 specifies the bottom right, and the top word, the top 16 bits, are the X coordinate, and the bottom one is the Y. The bottom word is the Y coordinate, and that's a common thing we're going to see again later on. So we've split the X and Y position into two there, and we store them in one register. So we've defined our 2 points, and that defines the range that the window is limited to, that the mouse is limited to. Sorry. So here I'd got it specified to 1 double F to 0 double F here, but we could change this. We could maybe change this to 3 double F and 1 double F, and we could maybe put a thing in here. Let's just skip the very start of the screen. So now we're a bit more centralized here. I just capture my mouse here. Okay, so now I can't get to the top left corner, and I can go down. I can probably actually go off the screen there, which might get a bit weird, but we can specify a large range there if we so require. So we can specify our range there with function 77. Another one that might be useful for us with that, and possibly other things as well, is function 76, which allows us to reposition the cursor. So originally in the settings of this was setting it to the center of the defined area, but now it's quite a long way off the center. But again, the top word is the X position, the bottom word is the Y position. So both X and Y are specified in a single register here, and we use function 76 again with trap 15 to specify that cursor position. So if we put in 0 and 0 here, then we are going to be selecting the top left. Actually, that's outside of our limited window, so we've actually gone to, it's figured out my silly mistake, and it's put us at the top of the valid window there, so it has actually corrected that for us. Now this is a time to discuss another quite interesting thing. The X68000 mouse driver actually has a built-in soft keyboard. If I right click here, you can see we've got this soft keyboard here, so we can simulate key presses, I guess, but we're probably not going to want that in our gaming. It's probably going to cause us some trouble. So what we can do is we can turn that off, and that's actually part of trap 15 as well. This is function 7D, and if we specify D1 to 0, that will turn the soft keyboard off. If we run again now, and I just capture my mouse here, well, we can move our mouse again, and we can right click to our heart's content, and that soft keyboard is not going to appear, so that's going to be a lot better for us. Okay, so that's how we can set our mouse up and how we can get the ranges we want, and if we want to see a cursor, and if we don't, we can hide it. But what about actually reading from it? Well, again, trap 15 has a couple of functions to help us out here. So what we're doing here is we're using my monitor function to show all of the registers to the screen, and we've just got some code here to move the text cursor to the top corner of the screen there, so that's not part of the mouse reading routines. We've got two options for reading the mouse, and we might need just one, or we might need both. Function 74 in hexadecimal will read in the current movement of the mouse, how much the mouse is moving, so if the mouse is moving to the left, or if the mouse is moving to the right, and also the two mouse buttons, the left mouse and the right mouse. The function 75 gets the current position on the screen, the XY coordinate, in the same format as before, where the top word is the X coordinate and the bottom word is the Y coordinate. So this is an absolute position, so 0, 0 would be the top left, whereas this is a relative position. This X and Y byte here is a relative position, so 0, 0 means it's not moved, and 1, 0 would mean it's moved to the right, and -1, 0 would mean it's moved to the left, and up and down would be 0, -1 and 0, 1 as respectively. And we'll see that in action in a moment. But these might be a bit misleading because we're actually we've got a sort of delay in here, and so we're missing some of the mouse movements there. So that's how we can read the mouse buttons and relative movements with hexadecimal 74, and hexadecimal 75 will read the absolute position on the screen. Now function 74 returns its result in D0, but we're actually pushing it into D1 here via the stack because function 75 also uses D0. So we're going to see our mouse button result in D1 and our cursor position in D0. So if we just fire this up here. Now the ones we're going to need to look at here are D0 here and D1, but I can't actually do the zoom because the mouse cursor is being captured. So I'll just have to read out what's happening. So if I move to the top minimum area of the valid range, D0 equals in the top word hexadecimal 40 and in the bottom word hexadecimal 40, and that's because the X coordinate is 40 and the Y coordinate is 40. But as I move to the right, D0 is going up, the top word is going up, and that's because the X position is changing. But then as I go down, the bottom word is going up because the Y position is changing, and as I say, we're basically getting the full range of positions, and they're being returned in D0. Now D1 is also changing as I move to the right. The top byte is flipping to 1 as I'm moving to the right. As I move to the left, it flips to -1, and that's the relative movement of the x-axis. And the next byte, the second byte, is also the same. If I move up, that goes negative because moving up the screen is negative, and if I go down, it goes to positive. And in classic style, there's a bug in my code and it actually crashed. I was neglecting to remove these items that I'd pushed onto the stack here. These functions don't take off the items from the stack, so my program crashed as the stack got full. Hopefully we fixed it now so we can carry on our testing. Anyway, so we're getting the relative movements in D1 there, but the left and right mouse button are also being returned in D1 by that function 74 there. And so if I click the left mouse, the third most significant byte is being changed to FF. It's 0 when the button isn't clicked, and the least significant byte, the last byte, is being affected by the right mouse. Now function 75 doesn't return the mouse buttons, it's only function 74 that does. So we can use function 75 to get our mouse position, but we would also want to use function 74 to get the buttons. Now, which one of these you would want to use would of course depend on your game. If you're trying to create a real-time strategy game, then this valid area, it would be very appropriate, because you would want to be able to click on certain positions on the screen. Whereas if you're making a first-person shooter, you would want to use the relative movements, because you're going to want to be able to turn infinitely, and you're not going to want any particular pixel coordinates off the screen. So it's really going to depend what kind of game you're writing, which one of these would be more appropriate. These functions get the mouse values very well, they make the mouse very easy to use, provided there isn't any silly bugs in your code like there was in mine. Anyway, there you go. If you liked what you've seen, you can go to my website, as I said, and download the source code and have a go with it yourself. And as I always say, you're welcome to use the code in any way you can, feel free to benefit from it as best you can. You don't need to give me credit for it if you manage to use it in some kind of game you make, because that's what it's there for. Anyway, one thing I would like to tell you about today is I've actually written a book. It's called Learn Multi-Platform Assembly Programming with Chibi Akumas. It should be, by the time you see this, available on Amazon in print and digital. The book covers Z80, 6502, 68000, 8086 and ARM. It's a beginner's introduction. It covers basic terminology and concepts you're going to come across in programming. And there's an instruction set summary for all of those processes, as well as a few simple examples to get you started. So if you want to support this channel, or if you want some reading material or a reference book to quickly look things up, please take a look at the link below in the description for the details of how to buy it, because as I say, by the time you read this, it should be available from Amazon. Anyway, I hope you've enjoyed this video today. Thanks for watching.